Hey, hi, Rajan this side. Welcome back to the channel. So today we'll discuss all four problems asked in today's LeetCode Biweekly Contest 171. Let's look at the first problem. You are given an integer num and the number num is called complete prime number if every prefix and every suffix of num is a prime number, right? So we have to return true if the number is a complete prime number, otherwise return false. So for example, in this 2, 3, if you see how many prefixes are there? 2 and 2, 3, right? And both are a prime number. Now, if you look at the suffixes 3 and 2, 3, right? And also both the suffixes also are a prime number. So all like every prefix and every suffix is a prime number. So it's a complete prime number. So we have to return true here, right? So, but in this here, if you see 3 is a prime number, but 39, like the prefix 39 is not a prime number, right? Because 13 can divide this number. So this is not a prime number, not complete prime number. So we have to return false. 7, we have to return true, right? So it's a easy problem. What we can do, we can go through each possible prefixes and each possible suffixes, and we can check whether that number is a prime number or not. Because like to check the prime number, we can easily use a square root of an algorithm solution, right? So yeah, let's look at the code. So here is the easy code. So I have created a function is prime that takes a number and it just check if the number is prime or not. And to check the number is prime or not, we can easily use a square root of n solution, right? So if the number is less than 2, return false. If the number is divisible by 2, but if it's not 2, right? Because if the number is 2, it's a prime number, but if it's a even number but it's not equals to 2, then all those numbers are not a prime number, right? So just check if x is equals to 2 or not. Now if the number are odd, what we can do, we can easily use a for loop from I equals to 3, I into I less than or equals to x, I plus equals to 2, right? So this is the standard algorithm, right? So here the complexity is order of square root of n, square root of x, and just check if any of the number divides this number x. If any of the number divides, just return false, that is not a prime number, otherwise return true. So this function just check if the number is prime or not, and apart from it, the code is easy. Just go through all possible prefixes, like generate all possible prefixes and just check if the number is not prime. If the number is not prime, right, if the current prefix is not prime, just return false, because the number would be complete prime number if every prefix and every suffix is a prime number, right? So as soon as you get any non-prime prefix, just return false, and similarly as soon as you get any non-prime suffix, return false. So this codes generate all the suffixes and this code generates all the prefixes, right? And at the end, if everything is, if all prefixes are a prime number and all suffixes are a prime number, just return true, right? So yeah, that's all about the first problem. Now let's look at the second problem. Here is the second problem asked in today's contest. So it says you are given integer array nums, and for each element nums of I, you may perform the following operation in number of times, right? So what we can do, we can increase the nums of I by 1, or we can decrease nums of I by 1, right? And a number is called binary palindrome if its binary representation without leading zeros reads same from forward to backward, right? We know what is a palindrome and we know what is binary palindrome. So the objective in this problem is to return an integer answer where answer of I represents the minimum number of operations required to convert nums of I into its binary palindrome, right? So for example, this, let's say this is your nums array. What we have to do, we have to convert each individual nums of I to its binary palindrome by following these operations. So you can either increase it by 1 or you can either decrease it by 1, and we can perform this operation any number of times, right? So for example, 1, 2 and 4. So this is the binary representation of 1, 2 and 4. If you see, this is already a palindrome, so no need to apply any operation. So the number of operation is 0. For 2, if you see, this is not a palindrome, and to convert into palindrome, the nearest number is 3, and the number of operation required is just 1, just incremented by 1. So it would become 3 and the number of operation is 1. Now for third, like for number 4, the binary representation is 100. This is also not a prime number, right? Sorry, this is also not a binary palindrome. So the nearest number which is a binary palindrome is Again, I believe 3 itself. Yes, correct. So, but here in this case, you have to subtract it by 1. So, if you subtract 1 from the 4, it would become 3, and 3 is also a binary palindrome. So, the number of operation is 1. But in the second case, you had to increment it. But in third case, you had to decrement it, right? So, increment it by 1 or decrement it by 1. So, yeah, I hope you understand this problem. Actually, this problem is if you observe it carefully, right, to convert any number to any other nearest binary palindrome, if you look at the test cases, right, the length could be I mean the number of elements could be 5000, and each element is up to 5000, right? So we can easily apply an order of uh, n square solution, right? Here order of n into m, like we can easily apply, because we know that for sure if you have a number is up to 5000, either you go 5000. Let me explain it in the whiteboard to let you understand it completely. So we know that your size of array, size of nums, right? Size of nums is only up to 5000, and your each individual a of I is individually also up to 5000, right? We know that we have to convert this a of I into nearest number, such that the binary representation of that nearest number is a binary palindrome, right? It has a binary palindrome. So if you observe it carefully, we can, since the number is up to 5000, for sure, if you go from AI minus 5000 to AI plus 5000, we can easily find a number, right? There must exist at least one number that would be a binary palindrome if you go in this range. And if you go in this range, the complexity would be 5000. Let's say that number is n into 2 times this 5000, right? 5000. So it's easily accepted, right? So what we can do, for each number we can go from minus 5000 to 5000, and we can check which is the nearest number which is a binary palindrome, and that's it, nothing else. So yeah, let's look at the code. So here is the code. I just created a function to check whether the given integer is a binary palindrome or not. So we can just generate its binary representation, and we can just check if that binary representation of reverse of it are same or not. So you can also write your own version of this function. So it just check whether the given integer is a binary palindrome or not. And after that, the job is easy as discussed. This is your current number x, and this is your d. Now what you do, while true, you go, so here what I'm doing here, I'm starting, so d is the difference, right? D is the difference. So here it will go x, so in the first occurrence it would be x minus 1, x minus 1. This will go to x plus 1. Like, so if neither x minus 1 nor x plus 1 is a binary representation, like binary palindrome, just go to x minus 2. Then it will check x minus 2, then x plus 2. If neither of x minus 2, x plus 2 is a binary palindrome, go to x minus 3, and x plus 3. Because we know that for sure, if the number is only up to 5000, I mean from x minus 5000 to x plus 5000, we can at least get one number that is a binary palindrome, right? So just keep on doing this process until you get the nearest number which is a binary palindrome, and yeah, that's it. Just return your answer. So here it will update your answer of I equals to d. So as soon as you get any nearest binary palindrome, just update your answer. Yeah, that's all about the second problem. Now let's look at the third problem. Yeah, here is the third problem. Actually, this problem is pretty easy. I mean, I found this third problem is much easier than first and second. Even you also would think the same by looking at the problem. So here it says you are given two integer array, technique 1 and technique 2, each of length n, where n represents the number of tasks to complete, right? So if the ith task is completed using technique 1, so if you complete the ith task using first technique, you earn technique 1 I point. And if you complete the ith task using technique 2, then you want technique 2 points, right? You are also given an integer k that represents the minimum number of tasks that must be completed using technique 1, right? So k is the integer. I mean, so you have to complete at least k number of tasks by using technique 1. So you must complete at least k tasks using technique 1 if they don't need to be the first. Okay, so they didn't, like, they don't have to be the first k technique 1. It could be any random, right? So out of all this technique 1, just like you must choose at least k tasks to complete using technique 1, and the remaining can be completed either using technique 1 or technique 2. It doesn't matter, it's up to you. So we have to find out the integer that denotes the maximum total point that you can earn, right? Yeah, let's see how we can approach it. So in second problem, we are given two arrays, right? Technique 1, technique 2. And so let's say there are n number of total tasks that you have to complete, and out of them, at least k must be completed using technique 1, right? And we have to find out what is the maximum points that you can earn, right? So we will do it in two steps. First step, let's assume you have completed all the tasks using technique 2, right? So let's say there are n number of tasks. All the tasks are completed using technique 2. Let's say T2, 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 right? So all these n number of tasks are completed using technique 2. So in this case, what will be your total points earned? So currently your total points earned is nothing but the sum of all these technique 2 points, right? So sum of technique 2 of I, right? For each I from 0 to n minus 1, right? So this is your current total score. But here like there is a catch. You can, like, you must complete at least k task using technique 1, right? So in the second step, what we will do, let's say the ith task is completed using technique 1. So in this case, what you have to do, you have to do total plus equals to, I mean, since you have already like included T2, right? So here what should be your score? Plus should be T1 minus T2, right? So earlier you have already encountered T2, so T2 minus T2 cancel out, and that would be T1 for this particular task, ith task. So what you have to perform, you have to perform T1 minus T2 for at least k tasks, right? Because earlier you already assumed that all the tasks are completed using technique 2. Now since k number of tasks must complete using technique 1 at least, then for those k number of tasks you must perform T1. So T1 means this technique 1 of I mean the points that is on using technique 1 minus technique 2, right? Because we have already added T2 here. So T2, if you do addition this, then this is cancel out, then it will be T1. So now it means that now this task is completed using technique 1. So what we can do, we can use a array called, let's say, gain, right? So gain of I is nothing but T1 of I technique, like the point value of T1 of I minus the points that is on using, like if you complete the task using technique 2, right? So what we can do, we can create an array of n numbers and tasks, and for each I we can calculate its gain. Its gain means if you choose this task to compute using technique 1, how many points you can gain. That gain is nothing but technique 1 of I minus technique 2 of I. Then what we can do, since we know that we have to kind of maximize your total score, right? To maximize the total score, isn't it better to choose those k number of tasks whose gain is at as max as possible? So just sort them in reverse order. So after sorting, let's say the first number is the max number, right? Max to mean. What we can do, we can take first k task, because because we know that like there is no option for this k task. This k number of tasks, at least k number of task has to be completed using technique 1. So you must choose the first k task because those are having the maximum gains, right? So just add these k numbers, and afterwards for these numbers, right, remaining n minus k, this is up to you. Let's say the gain is positive, then isn't it better to complete this task using technique 1? Like if the gain is positive, then it's okay. Like, so earlier you have chosen to complete that task using technique 2. But if you are gaining some extra points, right, extra points, then why not complete that task using technique 1? So after this k task, just check if your gain is positive, just do it using technique 1, and that's it. You solve this problem. So in short, first assume you completed all the tasks using technique 2. Now if you choose the higher task to complete using technique 1, your addition should be t1 minus t2, right? Because t2, you already have t2, so if you do t1 addition t1 minus t2, it will cancel out. Now you are adding only t1. It means that now this task would be completed using technique 1. So complete a gain. So have an array of n numbers, gain of I. Just sort them in reverse order. Choose first k, because there is no option. You have to choose at least k tasks to complete using technique 1. So do that. And after that, for the remaining tasks, just check if you are having some extra gains, positive gain. If positive gains are there, just add it. I mean, just complete the task using technique 1 in other terms. So yeah, let's look at the code now. Here is the code. This code is exactly how I have explained there. So this is the size, this is your total. First assume you have completed all the tasks using technique 2. So total plus equals to technique 2 of I. Now calculate the gain. Gain of I is nothing but technique 1 of I minus technique 2 of I. Just sort them in reverse order. Choose first k to complete using first technique. So your total plus equals to gain, right? This gain of I is nothing but technique 1 of I minus technique 2 of I. Now for the remaining tasks, right, from the remaining n minus k task, just check if your gain is positive. If your gain is positive, there is no harm to complete the task using technique 1 in order to maximize the total points. So just add the gain in the total score, and at the end return your total score. So yeah, that's all about the third problem. Now let's look at the fourth problem. So yeah, here is the fourth problem asked in today's contest. So it says you are given an integer array nums of length n and integer k. Now we know what is inversion. Inversion is the pair of indices I and j such that your I is less than j, but the value is more than nums of j, right? Nums of I is more than nums of j. This is the standard inversion definition. Now the inversion count of a subarray is the number of inversion within it, right? We have to find out the minimum inversion count among all subarray of size k. So, yes, yeah. So you have to go through all possible subarrays of size k and just find out its inversion, and uh, and among all those inversion of k length subarray, just print the minimum possible inversion, right? So yeah, that's all about the fourth problem. Now let's see how we can approach it. It's really good problem, right? It uses Fenwik tree. I have solved using Fenwik tree. Yeah, let's see how we can approach it. In fourth problem, if you notice, your length is only up to 10 to the power 5, but your numbers are up to 10 to the power 9, right? So we cannot apply directly, like we cannot create an array of size 10 to the power 9 or something, right? So what we will do something smart. Let's say your number, we know that the nums, like the unique numbers can be only up to 10 to the power 5, right? That is for sure. Though your number is up to 10 to the power 9, but the total unique numbers are only up to 10 to the power 5. So what we will do, we will convert into a compressed array. Maybe it sounds a fancy words, but it's very simple. Let's say your given array was something 3, 5, not 3, 5. Let's say your given number was something 10, 12, 11, 14, and let's say 9, for example, right? Let's say this was your original array, right? But what I will be doing, first I will convert, like I will sort them number, right? These numbers are 9, like if you sort them 9, 10, 11, 12, and 14, right? So for corresponding 9, what I'll be doing, I will now treat 9 as 1, I will treat 10 as 2, I will treat 11 as 3, 12 as 4, and 14 as 5. Now we will kind of do a reverse mapping. If you do a reverse mapping, then your 10 was what? 2. Now this 10 is 2, 12 was 4, 11 was 3, 14 was 5, and 9 was 1, right? So now what I'll be doing, this was your original given array. Now I will convert this array to this array, because to calculate inversion, it doesn't matter what is your number. It just matter if your I is less than j, a of I is greater than j, a of j or not. That's it. It doesn't care about what is your current number, right? It just care about this condition. And if you notice it here, this condition will exactly be satisfied in this array also. See, 10 is less than 10 is less than 14 and 12, right? See, 2 is less than corresponding 4 and 5, and similarly 10 is more than 9. See, 2 is more than 1. So this array is exactly same in terms of finding the inversion. Because, so why I am doing is that if you convert this array into this normalized array, we can easily apply an standard algorithm such as segment tree or Fenwik tree, because in those situations you have to create an array of these numbers, right? Whatever that max number is. So whenever you see a problem where you have to create a size that, like, the size is up to the max number, but the max number is up to 10 to the power 9. So just think about it. If you convert this array into if normalized array, this is like some people also call it normalized array. It's possible or not? Like the integrity of the problem shouldn't change, right? Here, if you see, if you convert this to a normalized array, your integrity of the problem is not changing. It's exactly the same. So it's better to use that. So that's what I'll be doing. I'll be converting this original array into this normalized array. This is pretty easy. Just keep all the unique numbers, sort them, find the indices, and just convert this into this array, right? After that, in this problem, we have to find out the minimum inversion among all k array k size subarrays, right? For each k size subarray, we have to find out the inversion, and among all those k inversions, just find out the minimum, right? So here what I'll be doing, let's assume this is your k size subarray, right? And I want to slide it. So I'll be using some sliding window kind of mechanism, right? For each k window subarray, right? I'll be kind of sliding it right side by 1. So if you so let's say for this k size subarray, the size of this subarray is k. The size of this subarray is k. Let's say for this k size subarray, I have already calculated the inversion value, right? Let's say that inversion is something inversion, right? I already have inversion calculated for this k size subarray. Now let's say I slide this subarray by 1. So now you have to include this number and you have to exclude this number, right? So this number should be removed, not this number. This number, the last number here, or this number should be removed and this number should be added, right? So let's see how is your inversion affected using these two numbers. See, for these numbers, your inversion is not going to change, right? For the subarray, your inversion is not going to change, right? So the only thing that matters is what are the values of these two numbers, right? So this included number and this excluded number, right? So let's first handle this excluded number, right? So we know that for this subarray, right, for this subarray of size k, the inversion using this was contributed in this INV, right? This inversion value. And what would be those inversion? That inversion would be what are the numbers? I mean the count of number in from the next element onwards, right? In this subarray, like the inversion, like the contribution of inversion by this number would be how many numbers are there in this range whose value is less than that x, right? Because we know that for the inversion these two conditions should be satisfied. The first condition is already satisfied, like the index of that number is anyway less than all these numbers, and the value should be more than these numbers, right? So just check how many numbers are there whose value is less than this number, right? Less than this number. So that we can calculate using Fenwik tree. So in a Fenwik tree, we would be storing information based on this array, right? Based on this array, because we know that this array is exactly the same in terms of finding inversions. So I would highly recommend to learn Fenwik tree. I mean, what is Fenwik tree, how it works, because in this problem, I'll be directly applying how Fenwik tree is used in this problem, right? I won't be able to explain in this video only. So maybe if you need, I can create a separate video for the Fenwik tree in a detailed manner. So yeah, here what we will do, we will first remove it, like remove that number and just check um, how many numbers are there which is less than b. So that inversion minus equals to whatever that value is. Let's say that value is k1, right? Now for this number, right, so that is done, this part is done, we have handled this excluded number. Now since that number is already removed, now your subarray is, like the size of the subarray is k minus 1, right? Now you want to include this number, right? So to include this number, now let's see how your inversion is affected by this number. So we know that for inversion these two conditions should be satisfied. So the first condition is already satisfied, this the index of that number is more than these numbers. Now to let the inversion count increment, your current number has to be smaller than these numbers, right? So your contribution would be, like the inversion for this number would be how many numbers are there whose value is more than x, right? For this, for the excluded number, we had calculated how many numbers are there which is less than this number. But for the added number, we have to calculate how many numbers are there whose value is more than this number, right? This added number, let's say that number was x. How many numbers are there whose value is more than x? Let's say that count is k2. So your inversion would be incremented by that k2, and that's it. This is your current, like this is the inversion value of this slided, I mean, so when, like once you slide this window by 1, now your inversion would be calculated based on this these values, right? So just find the minimum inversion among all those subarrays of size k. So yeah, I hope you understand. So this is the approach. Now to calculate, right, to since here we have to kind of update and query, right? So once you remove it, your updation values would be -1, like your contribution should be -1. -1 means you have removed it, and if you want to add the number, your contribution would be +1, right? +1 and -1. By -1 if you remove the number, and +1 if you add the number. So this is the update part. This is the update part. Now there would be a query part, right? There would be a query part. So this query function should tell you how many numbers are there whose value is less than me or greater than me. So the thing is, we cannot like it's not optimal to create multiple one function to give you the minimum number, one function to give you the max number. Let's create just one function that gives you, let's say, the less number, right? Let's say let's say you ask a query x, so it will tell you how many numbers are there in the subarray whose value is less than x. We know that the total array size is the total array size is k, right? And let's say that query, like this query like gives you count cnt. So to find out the like the smaller number, it's okay, this count is your value. But let's say you want to find out how many numbers are there whose value is more than me. So we know that these are the total numbers k. So if you subtract this value k minus count, these are the numbers which is more than me, and that's it. Like, so like you can do something smarter in your implementation, but it's okay. Like even though if you create two multiple function, but it's okay. But in generally in Fenwik tree we used to have just one query function, right? So yeah, that's all about the fourth problem. Now let's look at the code. Here is the code. This is the standard Fenwik tree implementation update function and query function. So this query function would tell you how many elements are there whose value is less than x in the current window, right? This is my size. First I have normalized the array, right? So let's say this is my comp array. This comp array is originally nums. Then I have make it unique, right? For sorted, erase all the duplicates numbers. So this will give you an comp array of unique numbers, right? Now what we have do, now I have done, I have for each ARR of I have found its index value, right? Its index value in this comp array, and that's it. So yeah, this will give you a normalized array as mentioned in the explanation, right? For this array, now your normalized array would look like 2 4 3 5 1. So now, and after that the job is easy. See, for the first k size subarray, right? So we cannot slide the window. We have to calculate um the inversion of the first k size subarray. So for that, so this query would, so we know that since here you have to add the number, right, because like there is no exclusion, because this, the size of the array is even less than k. So we know that this query will give you the smaller number, but once you add the number, you have to find out those number whose value is more than me, right? Whose value is more than me. So what I have done, so among all these ith number, just subtract how many numbers are smaller than me. So these numbers would be greater than me, and that essentially your inversion. So just increment your inversion. This current is essentially your inversion, and now update value. So since now you want to add this number, right? So to add, we would be contributing at +1. Now, so after this, your first k size subarray would be calculated, the inversion value. This is your answer. Now for index k to n, what we will be doing, we will slide this window by 1, right? So this ith number would be added and I minus kth number would be subtracted, right? Removed. So just remove it, and just subtract your inversion value. Now now your current ith number would be added, right? So now you have to include this ith number. So to calculate the inversion value, first find out the smaller number and subtract it from the size k. I mean, so this is the formula. Just subtract it from the total size. This will give you the contribution of inversion for the ith number, and just update your I mean, just add this number. So to add, we would be contributing at +1 in the update function, but we will pass +1. And if you want to subtract it, if you want to remove it, contribute to -1 in the update function. And at the end, update your current answer should be minimum of answer comma current inversion, and return your answer, right? So yeah, that's all about the all 4 problem asked in today's contest. If you find the video helpful, please like, share and subscribe to my channel. Yeah, thanks for watching.